In this video, I'm going to walk you through several different examples of what you can see in a molecule that we started working on together. Now, keeping in mind, the only thing that we've covered was coefficients and subscripts and really what that means. And now we take a look at several different examples of molecules. Now, some of these examples start off with very simplistic variations of just counting the atoms and how many you have for each element, while others start to include the parentheses as well as the coefficients involved. And we'll walk through to show you, what each one means. Okay, so take a look at keeping track of atoms for beginners part 1. That's located in your folder there. And go ahead and just kind of keep that open and we'll walk through it together so that we both have the same information and we're all on the same page. Okay, so the first few questions about subscripts, what it means in the formula, what it indicates, those are questions that can be answered if you look back at your notes that we took yesterday. It's all there. Okay, so what I'm going to scroll down to is question 4, when it starts actually counting how many atoms I have for each element within the molecule. So take a look at the example that's already done for you if you follow my mouse. Here I have C6H12O6. I have carbon, hydrogen, and oxygen. Each box listed is for one element within my molecule, and the number represents how many I have for each one. Now if you notice it says C6, that 6 is my subscript that tells me how many C's I have. It only applies to the element right before it. So in this case, that 6 belongs to my C and my C only. Hence why I have H12. The 12 applies to the H and the H only right before it. So I have 12 H's and then 6 O's. If you look at the example right below it, H2O, I have listed in each box separately each element. I have an H, in my next box I have an O. I have 2 H's because the 2 belongs to the H and the H only, and then I have 1 O. Because remember, there's no subscript, which tells me that I just have the 1 by itself. Okay? Now again, each rectangular box there in blue should have a single element listed. Okay, so if I have 3 boxes, I should have 3 elements listed in each box. I'm sorry, 1 element listed in each box. Okay, so if you have an empty box at the end of it, well, you're missing an element from that molecule. So we'll do one more together, and we have SiH4. One box, it belongs to my Si. The other box belongs to my H because I have Si and H in my molecule. I have 1 Si and 4 H's. It's as simple as that. Now I'm going to go ahead and let you practice and pause the video if you need to and work on it. Okay, because I'm not going to go through every single problem. But what I will do is I'm going to go ahead and fast forward a little bit, and I'm going to get on to the next part, which has parentheses involved. Okay, so let's take a look at the very first example again done for you. FeOH3, and the OH is now parentheses. The subscript on the outside, that 3 there, only applies to the element right before it within the parentheses. Okay, within the parentheses. So it's still thinking the element listed before, but now it applies to everything within the parentheses. So if you notice, Fe is not in the parentheses, hence why I only have 1 atom of Fe. And you notice that I have 3 O's and 3 H's. Now keeping in mind when I have a subscript on the outside, I think of it very much like distributing in math class, as you would distribute a number to the outside to everything in the parentheses. So if you follow along, and I'll see if I can make a little mark here. That 3 gets distributed out. So again, I have 1H. So I would take 3 times my 1H, and I would get 3 H's. But it also applies to my O, like I mentioned. So I have my 1O times my 3, which would give me 3 O's as well. Hence my final answer of 1 Fe, 3 O's, and 3 H's. Now, let's go ahead and take a look at the next problem. Here I have Cr3, PO4 in parentheses with a 2 on the outside. I have each element listed. I have a Cr, I have a P, and I have an O. Each element for each box. I have 3 CRs listed right here, not in parentheses, but that 3 is right after. So I have 3 CRs. Now, my PO4 is in my parentheses. Again, there's a 2 on the outside, so that 2 gets distributed out to everything within the parentheses. Now again, distributing means multiplying. So I have a 4 attached to my O, and it gets multiplied times 2. So I take my 4 O's right here times that 2 on the outside, gives me 8 O's. I have 1 P, so 1 times my 2 on the outside gives me 2 P's. And there we have my final answer. Okay, again, pause it, update yours, okay, and you can type this in. You don't have to draw on it like I did. Okay, that was just easier for me to modify. And practice. Okay, again, remember, each box is going to have a space for each element. So again, in this next example, I have 4 boxes. I'll have Mg listed, a C, an H, and an O each box. If there's an empty box, that means you're missing an element. So keep that in mind, okay? Each element is signified by a capital letter, so keep that in mind as well. I'm going to go ahead and scroll down and look at my last, as soon as I can turn off this pen marking here. Exit drawing, there we go. And scroll down to the part where I now have coefficients. Now, if you remember from our notes, coefficients are the big number in front of each molecule. For example, take a look at my arrow. 5NaOH. So I have that listed as my example. And again, it's almost just like parentheses. Well, actually, it is just like parentheses with a number on the outside. I have to distribute to every single thing. In this case, it's going to be every single element after it, okay? But when I distribute, again, I think multiplication. So this 5 applies to every element after that coefficient. So not only would I have 5 NAs, I would have 5 O's and 5 H's. Hence why I have my final answer there being 5, 5, and 5. Again, it gets distributed out. So if I think of Na as being the number 1, because there's only 1 there, I would take my 5 times my 1 Na, and I get 5. I would take my 5 times my 1 O, and I would get 5 again. I would take my 5 and multiply it out to my 1H, and I would get 5 again. Now let's take a look at the second problem where I have coefficients and subscripts in the same problem. But it works the same way. So I have a 2 as my subscript right here in the front, and I have C6H12O6. I've already listed out my elements, a C, an H, and an O. And now I go ahead and distribute out that coefficient to every element afterwards. So in this case, I would have 2 times my 6, which gives me, oh, not very good at the writing there, 12 C's, 2 times my 12 H's, so 2 times 12 gives me 24, and now a 2 times my 6 for my 6 O's. So then I have 12 O's as well. Okay? Now, keeping in mind that is what the next couple look like. Now it does start to get a little bit crazy when it comes to having parentheses and coefficients along with my subscripts, of course. Okay, so if you've made it this far, all right, I would hold off on finishing it. You can try it. I would love for you to try it, but we're going to continue working on this in class when I get back on Wednesday. Okay, again, work through it, practice, for sure try it, okay, because I don't grade your homework based on whether it's right or wrong. I want to see you trying things, and no matter what, we're going to go over it together, okay? But again, trying it just so that you know, hey, maybe you could be right, maybe you're on the right track. But when it comes to some of these later ones here with parentheses, you still now have to do all of the same steps, but the multiplication just gets a little bit more. So if you have questions, you can always Google it. Stuff's on YouTube. You can ask Miss Gill. She's there. Otherwise, you can just wait, and I'll be back on Wednesday.